So I had in mind this experiment since some time. It's something simple, how to make a light bulb with a pencil lead, in this case these 0.5 millimeters pencil leads, 2B, and these are for click pencils, and there are lots of videos about this experiment, but maybe I made it a bit better, but sadly there is still a problem. The structure that I made for this experiment is quite simple. It's just the pencil lead that is connected with the screw-on posts. These screw-on posts are tightened with a really gentle force, obviously, to not crack the lead, and these are also straightened, put straight, because otherwise they'll put force on the lead and bend it or something. Anyways, the screw-on posts are connected with a copper wire, through a copper wire that is not soldered on the screw-on posts, just wire wrapped. The copper wires go to two wires, one that is soldered to this copper pipe, 6 millimeters, that is used to pump the vacuum, and there's also another wire that goes inside the copper pipe. There's a rubber grommet for sealing the vial here, and it's reinforced and also sealed with hot glue. Anyways, a little note is just that it's better if you torch beforehand both the lead, the pencil lead, with a blowtorch, and the screw-on posts, because otherwise they'll outgas or outmaterial something and blacken your vial in some way, especially at high power. So I'm pumping a vacuum on this light bulb here in this vial with this apparatus here, with this system. This is just an air conditioner compressor. This is capable of, like, I don't know, 20 pascals, maybe. It's a decent vacuum, but not enough for making vacuum tubes, just gas discharge tubes. Anyways, the vacuum in the light bulb has two beneficial effects. First of all, you will drain away the most oxygen from the light bulb, so the lead will not burn, because it's notorious that the lead will burn with oxygen and last just, I don't know, a few seconds. The second beneficial effect is that vacuum lets things stay at a higher temperature, so the lead will reach a higher temperature and make more light. And this is basically what I did here, and I succeeded at this. Anyways, the first times I tried the system, I made kinda two mistakes. First of all, I didn't torch it with this blowtorch, both the lead and the posts, so they outgassed, outmaterialed from them, and they blackened my vial a couple of times. And also, there is still a problem about the screw-on posts, the posts that sustain the lead, and this is the problem. The problem is that at some point the two posts that keep the lead melt. They melt on the spot that touch the graphite lead. Why? That's simple, because the lead is at a really high temperature, maybe also above 2000 degrees Celsius, and there is also an high current on the circuit here, because this thing draws 10 amps out of this transformer. I keep this transformer as at 18 volts. It goes down to like 14 volts or something, so this thing draws like 100 watts. The lead is like 1 ohm, and there's a catch, because with tungsten has a high electrical temperature coefficient. Instead, graphite does not, because graphite with the high temperature doesn't increase its resistance much. What does this mean? It means that the temperature of the lead is kind of the same in the center and the two ends, so the two ends are really hot, while a tungsten light bulb has the metal that presses the tungsten filament, and it cools down, and in that spot the resistance is quite low, so the resistance of the tungsten filament there is quite low, and the temperature is also low, and it keeps low. In this case, instead, the two ends are at a high temperature, and it melts the posts. And I had to clean this vial a couple of times from the metal that got projected on the glass, and it was also hard because, you know, metal is not so easy to clean. Okay, let's try this thing. The vacuum is already pumped, but I'm gonna keep the compressor on for having the best vacuum possible. When it makes this noise, the compressor is at maximum vacuum. Okay, the variac is on. Let's turn off my room lights and let's crank the variac. More power, and maximum. And this is the light that it makes. My room is dark. And off. Lights on, and it survived. Okay, let's try again for more clarity. Anyways, little note, the lead that is installed here is the first lead that I used. It didn't wear out at all. It just cracked sometimes on the edges because of the screws, and it got shorter. In fact, it draws more current because it's shorter. Anyways, I can let this thing turn on as many times as I want, as granted that I keep it on for little time, because if I exceed the time that this thing stays on, the posts start to melt and they blacken also the glass. And I also have to ensure that the contact on the lid and the posts is okay, because otherwise it makes sparks, etc. Anyways, let's turn on again the pump. The vacuum is already okay, but let's make the best vacuum possible. Let's turn off my room lights. As you can see, this is the illumination. Let's crank the variac. Maximum power, and this is the light. Okay, now down and off. Okay, now let's try with the classic system with just the lid under a jar without the vacuum from a pump. The last time the light bulb survived, the lid is always the same as before. It didn't wear out, and the posts survived for 2 times in a row. But now let's try this way. The lid is fresh, but it has been tortured for cleaning it and take away the clay, I don't know. Anyways, now I'm using instead just 10 volts SC. Okay, let's see. Variac on, lights out, and power. More variac, more variac, more variac. Okay. It makes light a bit. More smoke. Let's see how much it lasts. More power. Oops! And now the variac was at like 80%, 70%. It didn't last. Let's see. Okay. And yes, there's also the little detail that I already noticed with another lid tried in free air. It becomes, sorry for the exposure, it becomes very sharp. See? Because I arranged the crocodiles, the alligators, to not bend the lid much, so the lid is free to become very thin and break only when super thin. So does this thing work? Well, yeah, but with a note, because you can't keep this thing on for much time because it will melt the posts on the two ends. I had the idea of making the posts using the graphite from a motor brush and make two pads that squeeze the lead and insulate thermally the lead from the remaining metal structure. That was a really good idea, but it's incredibly hard to implement, so I gave up because this is just a small experiment and it was nice. It makes a lot of light, the lead doesn't wear out at all. Again, this is the first lead that I used under vacuum, and you can see the glass is blackened anyways. This is because the first time that I tried to film it for YouTube in this video, the contact here wasn't good and it sprayed out metal on the glass and I had to clean it, but it worked 2 times in a row, and if you don't ruin the contacts, it can work as many times you want in a row. Anyways, thanks for watching my video, and bye!